Hi, hello, welcome back to our channel. Today we are going to discuss about motion in a straight line crash course. Okay, already I have completed units and measurements, and one more thing is the waves. One is from first year, another one is from second year. So today once again we come back to our first year topic, motion in a straight line. Actually this is the part of the mechanics. It is the heart of all chapters. This concept not only in first year, in second year also we are using. If we know the concept of this chapter, it is easy to understand for the further topics. So come to our topic, motion in a straight line. First of all, what is the particle and what is the body? If any particle, you can say suppose this marker is there, this cap is there, and this board is there. So which is the particle? This is the particle and this is the body. Why? These dimensions are negligible comparing with this one. So simply you can say that the body which is having the negligible dimension, you and earth is there. You are the particle and earth is the body. So any body which is having the negligible dimensions. Now what we are saying, particles, electrons, protons, neutrons are saying. But nowadays you can split that also, that is the other thing. So electrons, protons and neutrons are the elementary particles. Those dimensions are negligible. Those are called the particles also. So that is the difference between particle and body. Then come to rest and motion. What is the rest and motion? See, we can't say always the body is at rest, and we can't say always the body is in motion. So whenever anybody will ask, suppose this body is at rest or motion, don't say this is at rest. So immediately we should raise the question with respect to what? So with respect to the reference frame only we can say that is it rest or motion. Look here, with respect to time this is at rest. Why? This position does not change with respect to time and surroundings. But earth is always revolving around itself and around the sun also. So with respect to the earth, this is in motion. So normal definitions in our lower classes, you know that if the position of the body does not change with respect to time, you can say this board, that cupboards and that buildings, trees, all you can say that those are at rest condition. And when we are taking the vehicles are in moving condition. Why? That position is changing with respect to time. You can say those are in motion. But when we are raising the reference frame, compulsory we have to say that with respect to this building, this is at rest. With respect to this is at rest because it doesn't change its position. But we are in motion condition. So like that you can say that rest and motion are relative to each other. Normal definitions are the position does not change with respect to time and its surroundings. You can say the body is at rest. If the position is changes with respect to time and its surroundings, you can say that the body is in motion. But here one important point, rest and motion are relative to each other. Rest and motion are relative to each other. Just now I said, suppose your friend is in bus. Two friends, one is the A, another one is the B. And one more friend is here. He is under the tree. With respect to C, both are in motion. But with respect to A, B is at rest. And with respect to B, A is at rest because both are occupying the space. That's why you can say one statement here. Rest and motion are relative to each other. Then our next topic is distance and displacement. Distance and displacement. What is the distance? Total path length covered by the body is called the distance. Then shortest path from initial position to or starting position to final position is called the displacement. Here also you can say total path of the length, but the difference is it is the shortcut from initial to final position. That's why when we are going through this, suppose we are taking common diagram here, you are starting at A and reach to the C. Your direction is from, first you are going from A to B, then you are going from A to C. So total path length, finally you reach to the final destination F here. So what is the total path length? Nothing but distance. And what is the shortcut? Where is initial position A? Where is the final position F? So initial to final, this is the 2 meters, this is the 10 meters. Total path length, there is no particular direction, that is called what? That is the distance. Total path length is nothing but distance. shortcut from initial to final position is called the displacement. And always you remember that it is a scalar quantity. It is a scalar, and this is the vector quantity. This is the vector quantity. Both are measured in meters. Unit is for meters, and both are measured in same dimensional formula L. But it is the scalar quantity and it is the vector quantity. Always you should remember that distance is greater than or equals to displacement. Our chapter name is what? Motion in a straight line. Suppose you are using the straight road A to B. Here what happens? 2 meters. Here distance is equals to displacement. If you are going through the different directions, at that time you can remember that distance is always greater than or equals to displacement. But in straight line motion and uniform motion, both are equal. First of all, what is the uniform motion? If the body covers equal distances in equal intervals of time, that is called the uniform motion. Suppose you are taking, what is the uniform motion? Look, AB, here gap is 10 meters, here gap is 10 meters, same time it takes 5 seconds, 5 seconds, 5 seconds, like that, 10 meters, 5 seconds. This is called uniform motion. Like that, what is the non-uniform motion? If the body covers unequal distances, here A to B, 10 meters it takes 5 seconds. Then 20 meters, it takes only like 10 meters only you are taking equal distances, 2 seconds. Then 10 meters only it will take 7 seconds. So it covers what happens, equal distances only, but time is different. So that is called the non-uniform motion. So this is about the distance and this is about the displacement. These are like normal definitions. But when we are going through the depth, there what happens, we have to calculate how to find out the distance and how to find out the displacement. You must remember the total path length covered by the body is called the distance. I want to give one application. Look here. We are taking one square. You have started from A, reach it to the B, then C, then D. Each side square means same 1 meter you are taking. Each side is the 1 meter. Okay. But here few conditions you should observe that. From A to B, what is the distance and what is the displacement? What is the distance, what is the displacement, and what is the ratio of these two? See, distance for understanding I am taking the S, displacement I am taking the X. See, from A to B, both are covering the same distance, same displacement, both are in straight line. You can say 1 meter, and ratio is how much? 1. Then A to C, 1 plus 1, because total path length is distance 2 meters, but displacement is shortcut, no? They won't give. You can think what is the shortcut? A to C, and you should apply the Pythagoras theorem under root 1 square plus 1 square, root 2 meters. Root 2 meters. This is the displacement. Can you observe that in straight line motion both are equal? In other conditions, displacement is, this value is 1.414. It is less than 2 meters. Then ratio is how much? 2 by root 2 equals to root 2 meters. Ratio, no unit, root 2 only. Like that, from A to D. A to D. See, 1 plus 1 plus 1, 3 meters. But shortcut is from how much? A to D, 1 meter. So the ratio is the 3. Like that, A to A. This is also very important. A to A total path length you can say 4 meters. 4 meters. But the displacement is, there is no gap between initial and final position. You can say it is 0. Here answer is 4 by 0 is the infinity. Like that you can solve any type of conditions to solve this one. So I think you got the full clarity on what is distance and what is the displacement. And one more example we are going to discuss, that is in the case of circle. In the case of circle, what happens and how you should find out the distance and displacement. For this you must remember that circumference of the circle is the 2 pi r. Look here. The person is started A, B, C, D. Finally he comes back to the like that. Okay, in this case the radius of the circle we should consider r. As usual, from A to A, what is the distance and what is the displacement here? No doubt total path length is nothing but circumference of the circle. You can say 2 pi r. But displacement is what? From initial to final position, there is no gap. So displacement equals to 0. Like that, from A to C. A to C distance is how much? Half of the circumference of the circle, semicircle. This is the pi r. But shortcut is how much from A to C? Diameter of this one. So r plus r, 2r you are getting. When we are taking the ratio pi r by distance is the s and this is the x. S by x is how much? Here infinity, and here r cancel, we are getting 5 by 2. Like that, from A to B. A to B, like this. Shortcut is this. This is r, this is r. Anyway, you can say that pi r by 2, that is the distance. Half of the semicircle, quarter of the circle. Then displacement is how much? Once again we can go through the Pythagoras theorem. Under root r square plus r square, we are getting r root 2. R root 2. So when we are taking the ratio, what happens? Pi by 2 divided by pi r by 2 divided by r root 2, which is cancel, these two cancel. Our answer is pi by 2 root 2. So like that, here also you remember that distance is greater than or equals to displacement. Then our next application is, this is about the distance and displacement. Then we are going to discuss about what is the speed and what is the velocity. Here many applications are coming. First we can go through the what is the speed. General formula, speed is the distance by time. Distance by time. S by t. Unit is what? Meter per second. Dimension formula is what? LT power minus 1. In lower sections also, distance by time. We are calculating the distance with respect to time. That is called the speed. But our speedometer, in our daily life, you can observe that speedometer is giving the speed. With respect to time, how much distance we are covering, it is giving. That's why that name is also speedometer we are using in vehicles. Look here. Then our next thing is the average speed. Average speed. Total distance by total time. Total distance by total time is called the average speed. And here you remember that we are taking speed is the scalar quantity. This is the scalar quantity. That to v equals to s by t. From this, v is the speed. T equals to s by v. Like that, s equals to distance equals to speed into time. You must remember these three formulas, because now we are going to discuss about in depth of that average speed. Look, first condition is if the body covers s1 distance in t1 seconds, s2 distance in t2 seconds, like that sn distance in tn seconds. Here how to find out the average speed? You know that total distance we can take it s1 plus s2 plus and so on sn divided by t1 plus t2 plus and so on tn. Here we do one problem also. Suppose this is the 2 meters, this is the 3 meters, s3 is the 5 meters. This is 2 seconds, this is 3 seconds, and the next thing is the 2 seconds. How to find out the average speed here? Because n is the number of terms. If it is having only 3 terms, you can take only 3 terms. So total distance is how much? 2 plus 3, 5. 5 plus 5 is the 10. So 10 by, this is time is how much? 5 plus 2, 7. So unit is the meters per second. So 10 by 7. Average speed of this one is how much? 10 by 7 meters per second. Then come to our next application. See, if the body covers s1 distance with v1 speed, they didn't given the time here. Then s2 distance with v2 speed. Like that, sn distance with vn speed. In this case, how to find out the V average? No problem with numerator, same thing, S1 plus S2 plus and so on, Sn. But denominator is how much? T1, T2, like that. Just now I said T equals to distance by speed. First distance is how much? S1. So instead of T1, what we are writing? T1 equals to S1 by V1. T2 equals to S2 by V2. Like that, Tn equals to Sn by Vn. So here we can write it S1 by V1 plus S2 by V2 plus and so on, Sn by Vn. Like that we can take this application. So don't stick only for distance by time. Even you know the speed also, we can able to find out the average speed. See, here we are also doing one more application. This is 1 meter, 2 meters. This is the 5 meters. Here speed is the 2 meters per second. This is the 3 meters per second. And V3 is the 6 meters per second. How to find out the average speed? Look here, this is somewhat difficult. Anyway, 2 plus 1, 3, 3 plus 5 is the 8 meters. But here when we can go through the individual, S1 is how much? 1. And V1 is how much? 2. So T1 is how much? 1 by 2. Like that, T2 is how much? 2 by 3. Plus T3 is how much? This is the 5 meters. So 5 by, here we are taking 5 plus 3, 8, okay, 5 by 6. So here you can take the LCM and you can find out this, what is the average speed of this one. So this is in terms of speed and distance, this is in terms of speed and time. Here we find it one more application. This is very, very important. Look here. If the body covers half of the distance, very important for IPE also, half of the distance I am taking S by 2 and remaining half of the distance is with speed V1. This is the V2. Here how to find out the average speed? Look here. Numerator we are taking S by 2 plus S by 2. Denominator, instead of T1 what we are taking? S by 2 divided by V1, S by 2 divided by V2. After simplification you take the common and you should cancel this one. Here average speed equals to what we are getting here? V average equals to, see, 1 plus 1 how much? 2. Here LCM is how much? LCM is here 1 by 2 V1. 1 by 2 is cancel here. Here S by 2 is the common. So 1 by V1. If you want detailed explanation, we can go through the one more step. Look here. Don't confuse. It's very, very important concept. Here V average equals to S by 2 plus S by 2 divided by time is S by 2 V1 plus S by 2 V2. Here S by 2 is the common, we are getting 1 plus 1. Here also S by 2 is the common, we are getting 1 by V1 plus 1 by V2. S by 2 cancel. Then V average equals to how much? 2. LCM will reverse, V1 V2 divided by V1 plus V2. This is the crash course. Try to understand fast. What is the average speed if the body covers half of the distance? In your problem they will mention that half of the distance with V1 speed and remaining half of the distance with V2 speed. Immediately, no need of doing this one, direct formula you can use this one, 2V1 V2 by V1 plus V2. Not only this one, you are starting from home to market, then market to home. See, half of the distance, home to market is the half of the distance and coming back is the remaining half. In this case also, for finding the average speed, we can use the 2V1 V2 by V1 plus V2. So this is the second application. We do few problems based on this. See, if the person starts from home to market with a speed of 5 kmph and he is coming back 10 kmph. Look here, the given data is the person started from home to market while going speed is the 5 kmph and while coming back V2 is the 10 kmph. The question is, what is the average speed in this case? So in that problem only they didn't given half distance, but we should understand this, because home to market half of the distance, market to home is the remaining half of the distance. The given data is they have given half of the distance speed, they have given remaining half distance also they have given the speed. So here directly you can use 2v1 v2 by v1 plus v2 formula. So 2 into 5 into 10 by 10 plus 5 is how much? 15. So answer is 20 by 3, 6.7 kmph. Approximately 6.7 kmph. Like that, within fraction of seconds we can solve these problems. Like that, one more problem. If the body covers, they are giving directly half of the distance with 2 meters per second, remaining half of the distance with 4 meters per second. Find the average speed. Find the average speed. Immediately what we are taking here, 2v1 v2 by v1 plus v2. So 2 into 4 by 4 plus 2 is the 6. So 8 by 3. 2.6 meters per second. See, in this the problem they have given in terms of kmph, and here they have given this is in terms of meters per second. Not only this one, see our next application. If the body covers 1/3 of the distance with v1 speed, second third of distance with v2 speed, last third of distance v3. See, here the total distance is covered in divided into 3 parts. Here how to find out the average speed? No problem with the numerator. Simply we should write it s by 3 plus s by 3 plus s by 3. Then we can go through the T1. S by 3 distance by speed, s by 3 v1. T2 is how much? S by 3 v2. And Tn is how much? S by 3 vn. So here s by 3 v1 plus s by 3 v2 plus s by 3 v3. Here after simplification what we are getting? V average equals to s by 3 is the common. Within brackets 1 plus 1 plus 1 how much? 3 you are getting. Here also we are taking s by 3 is the common. Within brackets 1 by v1 plus 1 by v2 plus 1 by v3. See, s by 3 cancel. Here V average equals to how much? 3 into, take the LCM, v1, v2, v3. It is coming reverse and you will get it like this. LCM is, this one means first part we are getting v2, v3 plus, then the next one is the v1, v3 plus v1, v2. See, directly you should remember that for 1/3 of the distance you can take it 3 v1, v2, v3. For remembering easily we should write it, remember that v1, v2 plus v2, v3 plus v3, v1. Like that 1/3 of the distance also, if you remember the formula, within fraction of seconds we can solve these problems. Here look, one problem we are doing. If the body covers first 1/3 of the distance 10 kmph, second 1/3 of the distance 20 kmph, and last 1/3 of distance 60 kmph. Look here. First 1/3 is the 10 kmph. Second third is the 20 kmph. Then last one is the 60 kmph. Here how to find out the average speed? No need of going that entire process. Simply we can go through the 3 v1, v2, v3 by 3 v1, v2, v3. v1 is the 10, v2 is the 20, v3 is how much? 60 by v1, v2, 20 into 10 is how much? 200 plus v2, v3, 1200 plus v3, v1, how much? 600. For easy simplification, here take 100 and you should cancel here. Then V average equals to how much? 6 2 ja 12, 12 3 ja how much? 36. 360 by, this is 14 plus 6 is the 20. After simplification 18 kmph. So try to understand half of the distance 2 v1 v2 by v1 plus v2. Then 1/3 of the distance we can go through the 3v1 v2 v3 by v1 v2 plus v2 v3 plus v3 v1. That formula we should use, and we can find out this one directly. Then our third application. So here just we have divided. First one is the total distance by time. Second one is the total distance by time we are expressing in terms of the speed. Our third application, look here. If the body covers v1 speed, with how much time it is moving, v1 speed in t1 seconds, v2 speed in t2 seconds, then last vn speed in tn seconds. Here how to find out the v average? Here no problem with the denominator, we should write it t1 plus t2 plus t3 plus and so on tn. But the problem is numerator we have to express in terms of the distance. We don't know about s1, s2, s3, so on, sn. Here you know that s1 equals to speed into time, v1 into t1. s2 is how much? v2 t2. Like that sn is how much? vn tn. So instead of s1 we are taking v1 t1 plus v2 t2 plus and so on vn tn. Like this. We are doing one problem. Look here. If the body covers half of the time with how much speed? v1 speed. Remaining half of the time with v2 speed. How to find out the average in this case? How to find out the average? Look here. So half of the, no problem with the denominator, t by 2 plus t by 2. But here s1 is how much? This one into this one, v1 t by 2 plus v2 t by 2. Take the common and you should cancel here. Your answer is how much? v1 plus v2 by 2. So don't confuse. 2v1 v2 by v1 plus v2 is for half of the distance. For half of the time we can go through the v1 plus v2 by 2. v1 plus v2 by 2. Look here, we practically do one problem. If the person covers half of the time 2 meters per second, remaining half of the time 3 meters per second. Here how to find out the average speed? Direct you can go through the addition of these two, 5 by 2. Our answer is 2.5 meters per second. Like that we can find out the average speed. And in few problems, look here, they are giving like this also. If the body covers half of the distance with how much speed? v1, and remaining half of the distance, in this half of the time is the v2 dash speed, and the remaining half of the time is the v3 dash. Here how to find out the average speed? See, don't confuse. First you can take this part. What is the average speed of this one? So we are considering this is the v2. v2 is the half of the time is direct, you can use v1 plus v2 by 2 formula. So v2 dash plus v3 dash by how much? 2. Now draw one more diagram for easily understanding. Half of the distance v1 speed. Remaining half of the distance is how much now? v2 dash plus v3 dash by 2. Then as usual we can go through the, here average speed is how much? 2v1 v2 v3 by 2v1 v2 by 2 into v1 into, instead of v2 we can take this one, v2 dash plus v3 dash divided by 2v1 v2 by v1 plus v2. v2 is v2 dash plus v3 dash by 2. We do one problem based on this. Suppose here v1 equals to 4 meters per second. v2 dash is the 2 meters per second. v3 dash is also 2 meters per second. How to solve this one? V average equals to 2 into, instead of v1 we can take it the 4, plus here v2 dash and v3 dash, 2 plus 2 4. 4 by 2 is the 2 divided by, this is the 4, this is the 2. After simplification, 10 by 6 meters per second. So like that depends on the situation. So I am saying to you, don't stick only for one formula, basic. From the basic, see how many applications we derived for average speed. Then our next part is the instantaneous speed. Instantaneous speed. Instantaneous speed. What is the instantaneous speed? The rate of change of distance is called the instantaneous speed. Means the time limit is very small, within fraction of seconds. When we are closing our eyes and we should open that, at that time immediately, suppose you are having that vehicle, fraction of seconds we are changing the distance. That is nothing but instantaneous speed. If you are solving this one, you must know about the some derivative formulas. I am giving few, try to understand this one. Look here, d by dt of means rate of change of this. T to the power of n is the n into t power n minus 1. Like that, d by dt of t square is how much? 2 into t by 2 minus 1, 2t. Like that, d by dt of t power 3 is there. We are getting 3t square. Like that, d by dt of t power 4 is there. So 4 into t cube. D by dt of, if any constant is there, constant never change with respect to time, you are taking 0. D by dt of 5 is there. 5 never change with respect to time, so it is 0. Suppose we are using now d by dt of 4t cube. Don't think it is 0 here. Constant we are writing. This is 4 times of differentiation of t cube, means 4 into, already you know that t cube is how much? 3t square. We are getting the 12t square like that. Suppose it is having more number of functions here. You must remember by heart this one, then only you can able to do that type of problems. D by dt of 4t cube plus 2t plus 6 is there. Then this how to find out the differentiation of this one? This is 4 into t cube is the 2t square. This is 2 into dt by dt. Split this one. Then d by dt of 6 is there. So after simplification, 6t dt dt cancel, 2 plus 0. Our answer is how much? 6t plus 2. Why I am giving these formulas? Look here. Average speed is over, normal speed is over, then instantaneous speed. They can give the formulas like this. Distance equals to s equals to 4t square plus t cube plus 6. Find speed at t equals to 1 second. How to solve this one? This is in terms of the function of the t, no? We know the distance. How to find out the speed? V equals to ds by dt. Now we should differentiate this one. 4 into d by dt of, split this one, t square, plus d by dt of t cube plus d by dt of 6. After simplification, 4 into, this is the 2t, this is the 3t square, this is the 0. But clearly they are asking speed at t equals to 1 second. Substitute in this, 8 into, this is 1, 3 into 1 square. After that, our answer is how much? 11 meters per second. So this is the use of the derivatives. With the help of that, we can find out the instantaneous speed. So in this day, we discussed about what is particle, what is the body, what is distance, what is the displacement, what is the speed, what is the average speed, and what is the instantaneous speed. Thank you everyone. Please subscribe my channel.